with one of the interesting settings that can help increase speed performance on your debugging session, which is the JTAG clock speed. If you open a typical CC XML file or target configuration file, this is usually what you see, and it shows how to access the advanced options by clicking on this tab. And if you select the emulator, you actually see a lot of details about it, about a lot of configurations about it. We're gonna concentrate on this on the short clip on the JTAG clock frequency. The JTAG clock frequency in general is set by default to the legacy or the standard 1149.1 speed of 3.368. This is usually a very good idea if you actually started with a new board, or you're actually starting to test your own custom board, as it actually works quite well if you follow the typical rules. You can always verify this. I have my BeagleBone connected to my 560V2 JTAG debugger, and it actually shows if you do a test connection among a lot of messages in here, you can actually see the sampling, the sampling of the JTAG debugger actually trying to sample different speeds, JTAG clock speeds, and it gives here the results of the operation. And basically, as a summary, it actually tells you whatever frequency is actually being used. So basically, you can hover on and then keep looking, and then you see that no failed results were happened. So chances are you actually have a good connection. And in this case, you can simply verify this by actually launching the target and taking a look at how it behaves with program loading, program execution, and all that. The test connection button is only part, it only tells you part of the story, because it actually transfers a minimal set of bits and bytes through the JTAG channel. But once you connect, it runs the gel, you can load a program here. So it actually loaded fine, which is a good indicative of a really good and stable connection. You can actually put it to run, and it just runs to the end and halts like that. If you turn it off, we can actually now play with its settings on the JTAG clock. You can simply start with a fixed, with user specified faster value. It suggests 35 megahertz. You can simply save and try the test connection again. Usually this is a good initial value, but the thing is, this maximum value is highly dependent on the PCB routing on the device, on the JTAG debugger you are using. If you see here, it actually failed on the 35 megahertz. You can tell that it's actually was not able to keep up with that speed. So what we have to do basically is actually start using lower speeds. For instance, I'll just try it 20 just to see. Oops. 20 just to see. Let's see if we can get some connection in here. We run the test connection again, and let's see how it goes. It seems that, yes, there you go. I have a good value, so I'm set at 20 megahertz as the final frequency. And no failed results, and perhaps I'm good to go here. Let's try it again. Okay, launching again. Keep in mind that you always have to terminate the debug session and start over in order to actually get a good reliable connection. You see what's interesting? Here at 20 megahertz, it failed to read the specific address. That actually indicates that yes, despite the super low level connection is reliable, meaning transferring a little bit, a small amount of data. As long as you actually get serious, then you start having read and write failures. So that's perhaps not a great speed to start off. So let's go back to our advanced settings, and you can tell that this is really a trial and error thing. You go to 15, and then you test the connection again. Actually, this will always run because the upper speed actually run fine, and it says it's fixed at 15. Everything's hunky-dory, so let's go again. Launching again, and let's see how it goes. It's still failing to read a specific register, so perhaps this may not be a good idea to actually crank up the speed too much on this device. Another thing that you can actually try to do is simply reset the device and start over. See, that was probably a reset issue. You can simply kill it. Let's go back to the 20 megahertz again. And let's launch it again. Perhaps the device was in a bad state. The gel initialization was not able to complete because the device was in a bad state from the previous run. Let's try again. Let's see how it goes. See, it ran fine. So that was a false alarm. Now I can try it again and load my code. See, it loads fine at 20 megahertz. So keep in mind that. So that's an interesting thing. Once again, I'm back to my target configuration, and let's slap up the old 35 megahertz. Perhaps not really. I tested at 35 and it failed. Let's try 30. You notice that this is actually a very recursive and somewhat involving process, but you can tell that I'm still failing at 30. So perhaps it's not really a great idea to increase the speed beyond 20. However, there's still another slightly setting that actually may help you if you actually have a rising edge on the TMS and TDO timing that usually yields good results for you to crank up the speed a little bit further. Let's see how the tests go. There you go. You got a good 30 megahertz just by flipping that switch. Okay? And you're still getting good results in here. So let's try it again. By the way, I'm glad that I'm using a 560V2 because it's extremely fast. Let's see how the gel file works now. Yeah, it failed again. Let's try it over to overcome that false positive that we got. Let me run the gel file script again. There you go. It ran fine. And let's load my code again. See, it's loading fine. So this time I'm actually getting a reliable connection at 30 megahertz, but with the JTAG lock and the rising edge, as I said before. I did some experimenting before, and I'm gonna save you from all this time until I actually go all the way to the incredible speed of 52 megahertz. That I was able to actually connect my V2 with my big old bone in the past. So let me show you this. There you go, 52 megahertz. Frequency is fixed at 52. Let's see how this baby performs. Still on the error that tripped me in the, before. Let's try it again. There you go. So I got it. Let me just let me load my code again. See, there you go. I have the code loaded and it runs to the end and other things. So I guess there'll be others other scenarios. I could do more testing and do all this funky stuff. So a few important comments, closing comments regarding this, iterative technique. Just recapping a little. Always use the advanced configurations of your target configuration device. Always keep in mind that the configurations typically tend to come with the default 10 megahertz. Always a good idea because it's the most reliable, especially if you're doing your own board. The other thing is it's always a trial and error experimentation with the fixed value. Some processors require adaptive if it's an ARM9 or something like that. But in this case, it's a Cortex. It's fine with a fixed. And play with the speed. And if you're reaching the top, always try to set the rising edge. Once you've done that, you can always play with the test connection, but know that the test connection does not tell the whole story. And also, another important thing is that not all the JTAG debuggers do allow this setting to be significantly relevant to your JTAG speed. XDS 200, for instance, or XDS 100 usually don't allow you to do that. Actually, they do allow to set the options, but they don't necessarily increase the speed of the connection and the data transfers.